Okay, good day everyone. Today we're going to take a look at um, the velocity of a wave and also some problems surrounding frequency, period, wavelength, and speed. So let's get right into it. So today we're going to define the velocity. So the velocity of a wave is given by V is equal to F lambda, where V is the velocity, or sometimes we call this one speed. Remember that velocity is a vector quantity. Okay, but we are dealing with one-dimensional physics here for now, so they could be used interchangeably. The frequency and lambda is our wavelength. Now, typically the SI unit for velocity is meters per second. Frequency, we can either write it as per second or hertz, as we saw in the previous video. Wavelength is in meters, typically, unless the question asks otherwise, we use these units, or we are required to convert. So this is a very important formula. We're going to be using it throughout today's class. So let's take a look at the question. So question 1 tells us a vibrating source with a frequency of 20 hertz produces water waves that has a wavelength of 3 centimeters. Calculate the speed of these waves. Well, notice we have wavelength in centimeters. We would prefer these to be in meters, so to change from centimeters to meters, we divide by 100. So the wavelength is 0.03 meters. The frequency is equal to 20 hertz. So therefore the speed is F lambda, as we just saw, which is equal to 0.03 multiplied by 20, which is equal to 0.6 meters per second. What is the period of a wave that travels through a spring at 2.5 meters per second and has a wavelength of 1.3 meters? So we have velocity is equal to F lambda, and we want to find frequency. So we could solve for frequency. So we get the frequency is equal to V over lambda. And we are given the velocity. The velocity is 2.5 meters per second, and the wavelength is 1.3. So this would be 1.92 hertz or per second. A wave travels at 10 meters per second if the wavelength is 0.10 meters. What are the frequency and period of the wave? So we have the wave travels, so velocity is equal to F lambda. We could find the frequency, as we saw earlier, by V over lambda. V is 10 meters per second. The wavelength is 0.1 meters. So this is 100 hertz. So we found the frequency, and recall from the previous classes, we know that frequency is equal to 1 over period. So that means the period is equal to 1 over the frequency. The period is equal to 1 over 100, which is equal to 0.01 seconds. Okay, so it takes a water wave 5.2 seconds to travel between two ducks that are 19 meters apart. An observer notices that 20 crests passes in the first 17 seconds. Find the wavelength of the water waves. Well, 20 crests, so if we recall what that is, this is the crest and this is the trough. Now, if 20 crests, so remember crest to crest is a wavelength. From this point to this point is a wavelength. So what does that mean? If 20 crests passes in the first 17 seconds, that would imply that we have 10 wavelengths in the first 17 seconds. And I hope that made sense to you all. So we have that 10 wavelengths passes in 17 seconds. So if you recall what frequency is the amount of waves passing per second. So if we have the amount of waves passed in 17 seconds, so we could get that is 10 waves over 17 seconds. That would be 0.58, well, 59 hertz. That's how we find the frequency. Now, we could also find the velocity of the wave because we are given the time, the distance between the two ducks. So we have, remember from our studies that velocity is equal to also distance over time or displacement over time. So assuming that the wave travels in a straight line, we get 19 meters over 5.2 seconds. And this will give us here our velocity of our waves. Which is equal to 3.65 meters per second. So now that we have frequency and velocity, we should be able to find wavelength. Remember, V is equal to lambda F or F lambda. So lambda is equal to V over F. So we have the wavelength is equal to 3.65, divided by 0.59. So the wavelength, allow me to write it right here. So the wavelength is equal to 6.19 meters. Okay, so I hope that makes sense to everybody. Part 5, or number 5, tells us a radio station broadcasts its radio signals at 9.26 by 10 to the 7 hertz. Find the wavelength if the wave travel at, well, 3 by 10 to the 8. So a radio wave is a light wave, and light have a steady speed of 3 by 10 to the 8 meters per second. So we can have that the wavelength, again, is equal to the velocity over the frequency. So we have 3 by 10 to the 8 divided by 9.26 by 10 to the 7, which is equal to 3.24 meters. Okay, and number 6 is our last question that we look at today. A sound wave produced by a clock 550 meters away is heard 1.5 seconds later. What is the speed of sound in air? Well, we have the distance that the sound have to travel, and we have the time that the sound travel for. So we have the velocity, or the speed of sound will be the distance over the time, which is equal to 343.3 meters per second. A sound wave has a frequency of 426 hertz. What is the period? The period is equal to 1 over the frequency. So that is 1 over 426, which is equal to 0.0023 seconds. And finally, the wavelength. So we call that V equal F lambda. So lambda would be, or the wavelength would be V over F. We know the velocity is 343.3. The frequency, we are told that is 426. So this would be equal to 0.81 meters. And that concludes today's class. I hope you all understood what was done here today, and I'll see you all in the next video.